Here we are. This is Calculus Integrals, Part 2, Day number 1 notes. We're going to do a little proof here. Let's start first of all with this. This is our friend. We actually just had a nice conversation about this. What do you suppose the integral of that would be? Which of our arc sine, right? So this would be arc sine of x. Don't forget, some of you did on the test, plus c. Okay. Now, what if I started to adapt this a little bit and change that value, this value right here, from a 1 to an a squared? Right, well, I want it to be a 1, because if it's a 1, then I can use what I know about arc sine, and then I can adapt it. Okay, so let's turn that into a 1. Okay, well, what do I have to do then? I'd have to factor out of everything in that square root an a squared. So if I factor out an a squared, that would make the first term a 1, and that would make the second term what? X squared over a squared dx. So I'm getting closer right here. I'm getting closer to something that I like, right? Something that looks much more like the derivative of arc sine of x. Let's continue. Okay. If I take the square root of a squared, what does that become? A. Nice. So I get 1 over a. I pull that a squared out of the square root, and then I'm left with 1 minus, and I'm going to take x over a, and I'm going to square it. All right, I'm going to group that. So far, are we okay with the algebra I've done? Okay, now we're going to go back to our friend LU substitution. Okay, what would I set u equal to here? X over a. Watch how filthy and awesome this is. If I set u equal to x over a, du is 1 over a dx. And look what shows up over here. Show 1 over a dx. Get ready, it gets cooler than that. I know, how could it get cooler than that? So I replace 1 over a dx with du. And what does this thing now become? 1 minus u squared. Oh my gosh. Look at that. Because I consulted my brain for a while, and then it just made sense to make x over a u. So the integral of this, now it's been made simpler. The integral of this, hold on, what happened to this 1 over a, Mr. Ludd? Oh. Oh, sorry, hold on. Sorry, hold on. It disappeared, right? We used u substitution. So this would be the arc sine of u plus c. Okay, am I done here? No, I'm close. Arc sine of x over a plus c. Okay, so what is this telling us? This is telling us this. What would be the integral over 1 over the square root of 9 minus x squared dx? It'd be the arc sine, now watch now, arc sine of x over a, which is what? Not 9, 3 plus c. Someone smarter than all of us. And you know what? They probably weren't smarter than all of us. It just probably took them 40 years, and all of a sudden, right before they died, they're like, that's it. That's it. And then they died, and then 20 years later, people were like, dang, that person's awesome. But during their whole life, they were just chucking shoes at them when they'd walk down the street and whatever. Yeah. Let's record it. All right, folks, catch you up. Right, the integral of 1 over x squared dx is arctan of x plus c. But if we change that to 1 over x squared plus a squared, we're going to factor out that a squared and make it look like such. Okay, now the next step is not my genius. It is some old person that's probably dead and was a tailor during the day, like I said. But they decided to do this. They decided to take one of the 1 over a's. Would you agree that 1 over a times 1 over a is 1 over a squared? Okay, so they did this. Is that what you would do, Victor? And then they used u substitution as well. And so with u substitution, the same thing happens. They used u equals x over a, du equals 1 over a dx. Okay. Hey, take the volume down a little bit. I need to get this across here. Thank you. Okay, so then let's replace here. What gets replaced by du? 1 over a dx, but there's still a 1 over a out in front. Right? So 1 over a dx gets replaced with du. So I'll put a 1 du here. So now I have u squared plus 1, sick, right? So the only difference between the two is now I have 1 over a times arctangents of u, which in this case is x over a, plus c. Now arc cosine is going to be very similar to arc sine except negative, right? So we'd work through the same process. So let's look at an application of this. I'm not going to work on these. I want to skip ahead to, let's integrate these two, g and a, right? G. Okay, so we said that looked like arc, which one? Arc sine. So I'm going to assume that this will end up being arc sine of something with like x over the a value, but I got to find a. So let's dig a little bit and figure out what it would be. Thoughts here? Okay, so we decided we're going to factor out a 9. So that 9 would come to the outside as what? A 3. So I'm going to have 1/3 the integral of 1 square root, sorry, of 1 minus, now let's split this thing up a little bit. Could I do this? You okay with that? So a in this case equals what? Well, maybe let me do it this way. Let me do it a different way for you. You might see it quicker this way. Instead of taking a 9, what should we take out? Let's take out a 4. Let's do it this way. Because I showed you one way, I should probably do it that way again. So it'd be 9/4 minus x squared. Oh, that looks a lot nicer, doesn't it? So if I take out the 4, it becomes a 2. What would 9/4, the square root of that be? 3/2. Oh, 3/2 is a. So we said that the integral of 1 over the square root of 1 minus x squared dx was arc sine of, well, let's say it's an a squared, x over a, right? So we're going to take 1/2 of the arc sine of x over a. Well, x over 3/2 is the same as 2x over 3. That was probably one of the higher level ones we will do. So we identified a as 3/2. So x over a would be x over 3/2, which is the same as x times 2/3. The 1/2 came out because we had to factor out the coefficient of x in order to get it in a form a squared minus x squared. Let's pause there for a moment and ask a question. Okay, are you thinking arc sine, arc cosine, or arc tan? On letter 3, number 3, 3i. Yeah, I'm thinking tan, right? I see 4 plus x squared. I don't see a square root. It's positive. So I'm going to first take out the 10 and make it look a little bit more like it should. Okay. Um, so I'm going to take out the 2. So I get 10 times the integral of 1 over 2 times 2 plus x squared dx. Okay, so then I'm going to take that 2 and bring it out here and make this a 5. And I want to determine what number squared would give me 2. Square root of 2. Right? So what is a? A is the square root of 2. Now recall, if I have the integral of 1 over a squared plus x squared dx, that's equal to 1 over a times the arctangent of x over a plus c. That's the proof we did. So let's take that information and now morph it into what we've got. Do you want to do use substitution here? Say no, please. No, I don't either. Right? I'm going to use my shortcut. Not going to use u sub. I'm just going to take my shortcut. I know this is an arctangent integral. I'm going to take x over a, and I'm going to take 1 over a on the outside. Now that would be definitely an acceptable answer, but a varsity answer, that would be root 2 over 2 arctan of root 2x over 2 plus c. Either of those two would be acceptable. Because you've rationalized the denominator, there's no radical in there. Yeah. Hey, folks at home, we forgot the constant out in front, so make sure that's 5 over root 2 arctan x over root 2 plus c, or in a varsity answer, 5 root 2 over 2 arctan, the same thing. Okay, that is the beginnings of inverse trig integrals.